The National Electrical Code, or NEC, provides guidance on many electrical installations, but the NEC does not require lightning protection systems to be installed. The NEC references NFPA 780 for information pertaining to lightning protection systems. NFPA 780 is the standard for the installation of lightning protection systems. Even though the NEC refers to NFPA 780 for information, the absence of a mandatory installation requirement in the NEC means that inspections of lightning protection systems are not required by the NEC. This does not mean that lightning protection systems are unimportant or that they should be installed incorrectly. It simply clarifies that, from an NEC perspective, because there is no requirement to install them, there is no derived requirement to inspect them. Many jurisdictions and insurance companies, however, may have their own requirements that are outside the scope of the NEC. It is important to understand the purpose and function of a lightning protection system. These systems are designed to protect structures from the damaging effects of lightning strikes by providing a controlled path for the lightning's energy to travel to the ground. Without a properly installed lightning protection system, a lightning strike can cause fire, explosion, and electrical surges that can damage or destroy a building and its contents. A typical lightning protection system consists of several components. Firstly, there are air terminals, also known as lightning rods. These are typically pointed metal rods installed on the highest points of a building, such as the roof. They are designed to intercept lightning strikes and provide a preferred point of contact for the discharge. Secondly, there are conductors. These are heavy gauge wires, typically made of copper or aluminum, that connect the air terminals to the grounding system. They provide a low impedance path for the lightning current to flow to the ground. Thirdly, there are ground electrodes. These are metal rods, plates, or grids buried in the earth that provide a connection to the ground. They dissipate the lightning current into the earth, preventing it from causing damage to the building or its contents. Fourthly, there are bonding conductors. These are used to connect various metal parts of the building, such as metal pipes, ductwork, and electrical systems, to the grounding system. This helps to equalize the potential between these metal parts and the grounding system, reducing the risk of electrical shock or damage. There are different types of grounding electrode systems. Firstly, there are ground rods. These are metal rods driven into the earth. Secondly, there are ground plates. These are metal plates buried in the earth. Thirdly, there are ground grids. These are interconnected grids of conductors buried in the earth. The selection of the appropriate type of grounding electrode system depends on the soil conditions and the size and type of the building. Proper installation of a lightning protection system is essential for its effectiveness. The air terminals must be properly positioned to intercept lightning strikes. The conductors must be properly sized and routed to provide a low impedance path to the ground. The ground electrodes must be properly installed to provide a good connection to the earth. And the bonding conductors must be properly connected to all metal parts of the building. Regular maintenance of a lightning protection system is also important to ensure its continued effectiveness. The system should be inspected periodically for any signs of damage or corrosion. The connections should be checked to ensure that they are tight and secure. And the grounding system should be tested to ensure that it is still providing a good connection to the earth. While the NEC does not mandate the installation of lightning protection systems, many building owners choose to install them to protect their property and occupants. A properly installed and maintained lightning protection system can significantly reduce the risk of damage from lightning strikes. Additionally, some insurance companies may require lightning protection systems for certain types of buildings or in certain geographic areas. Even though the NEC does not require inspections of lightning protection systems, it is still important to ensure that these systems are installed and maintained properly. This can be done by hiring a qualified lightning protection system installer to perform the installation and regular maintenance. The installer should be certified by a recognized organization such as the Lightning Protection Institute or Underwriters Laboratories. These organizations provide training and certification programs for lightning protection system installers. Another important aspect of lightning protection is surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning strikes or other events. SPD are typically installed at the service entrance of a building and at various points throughout the electrical system. They work by diverting the surge current to ground, preventing it from damaging sensitive electronic equipment. There are different types of SPD available. Firstly, there are Type 1 SPD. These are installed at the service entrance of a building and are designed to protect against high-energy surges caused by direct lightning strikes. Secondly, there are Type 2 SPD. These are installed at distribution panels and are designed to protect against lower energy surges caused by indirect lightning strikes or switching events. Thirdly, there are Type 3 SPD. These are installed at the point of use, such as at an outlet, and are designed to protect individual electronic devices. The selection of the appropriate type of SPD depends on the location and the type of equipment being protected. Proper installation of SPD is essential for their effectiveness. The SPD must be properly grounded to provide a low impedance path for the surge current to flow to ground. The SPD should also be installed as close as possible to the equipment being protected. Regular testing of SPD is also important to ensure their continued effectiveness. The SPD should be tested periodically to ensure that they are still functioning properly. If an SPD fails, it should be replaced immediately. In addition to lightning protection systems and SPD, there are other measures that can be taken to protect buildings and their occupants from lightning strikes. These measures include grounding metal objects, such as antennas and satellite dishes, and avoiding the use of electrical appliances during thunderstorms. It is also important to be aware of the risks of lightning strikes and to take appropriate precautions. If you are outdoors during a thunderstorm, seek shelter in a building or a vehicle. Avoid being near tall objects such as trees or power lines. And if you are indoors, stay away from windows and doors. While lightning protection systems are not required by the NEC, they can provide valuable protection against the damaging effects of lightning strikes. Building owners should consider installing lightning protection systems and SPD to protect their property and occupants. It is also important to be aware of the risks of lightning strikes and to take appropriate precautions. The NEC provides specific requirements for grounding and bonding of electrical systems, which are essential for safety and for minimizing the risk of electrical shock and fire. Grounding refers to the connection of an electrical system to the earth, while bonding refers to the connection of various metal parts of the system together. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, allowing the overcurrent protective devices such as circuit breakers and fuses to trip and to energize the circuit. This helps to prevent electrical shock and fire. The purpose of bonding is to equalize the potential between various metal parts of the system, reducing the risk of electrical shock. When a fault occurs, the fault current can flow through any available path, including metal parts of the system. If these metal parts are not properly bonded together, a voltage difference can develop between them, which can create a shock hazard. The NEC requires that all electrical systems be grounded and bonded in accordance with specific requirements. These requirements vary depending on the type of system and the voltage level. For example, the NEC requires that service entrances be grounded to a grounding electrode system, which typically consists of a ground rod or a ground plate. The NEC also requires that all metal parts of the system, such as metal conduits, metal enclosures, and metal equipment, be bonded together. The NEC provides specific requirements for the size and type of grounding and bonding conductors. These requirements are based on the size of the circuit and the type of system. The NEC also provides specific requirements for the installation of grounding and bonding conductors. These requirements are designed to ensure that the grounding and bonding system is effective and reliable. In addition to the NEC requirements, there may be local codes or regulations that also apply to grounding and bonding. It is important to check with the local authorities to determine the specific requirements in your area. Proper grounding and bonding is essential for electrical safety. It is important to follow the NEC requirements and any local codes or regulations to ensure that your electrical system is properly grounded and bonded. This will help to protect yourself and others from electrical shock and fire. The NEC also addresses other aspects of electrical safety such as overcurrent protection, wiring methods, and equipment installation. It is important to be familiar with the NEC requirements and to follow them carefully when installing or maintaining electrical systems. The NEC is a complex document, but it is essential for ensuring electrical safety. By following the NEC requirements, you can help to protect yourself and others from electrical hazards. In summary, while the NEC does not require the installation or inspection of lightning protection systems, understanding their function and the principles of grounding and bonding is crucial for overall electrical safety. Consulting with qualified professionals and adhering to local codes and regulations is always recommended. Remember, the absence of a mandate does not diminish the importance of electrical safety practices. The NEC serves as a foundational guide for safe electrical installations, and continuous learning and adherence to its principles are essential for all electrical work. Furthermore, the NEC is updated every 3 years to reflect changes in technology and best practices. Staying current with the latest edition of the NEC is important for ensuring that your electrical work is up to code and safe. Changes in the NEC can affect various aspects of electrical installations, including grounding and bonding requirements, wiring methods, and equipment installation. Therefore, it is important to stay informed about these changes and to incorporate them into your electrical work. In addition to the NEC, there are other resources available that can help you to improve your understanding of electrical safety. These resources include training courses, seminars, and publications. Taking advantage of these resources can help you to stay up to date on the latest electrical safety practices and to improve your skills as an electrician or electrical contractor. Electrical safety is a shared responsibility. Everyone who works with electricity has a responsibility to ensure that they are working safely and that they are following all applicable codes and regulations. By working together, we can create a safer environment for everyone. Therefore, while lightning protection systems are not mandated and thus not inspected under the NEC, the broader principles of electrical safety, grounding, and bonding remain paramount. Upholding these standards, seeking professional guidance, and staying informed about code updates are crucial for ensuring the safety and reliability of electrical systems in any structure.